Everyone. Good morning, good afternoon, good evening, wherever you are in the world. Welcome to today's Bunnyshell webinar, Best Practices for Using Terraform in Your Developer Pipeline. Today we have two amazing speakers, Sorin and Aris. Sorin is VP of Engineering at Bunnyshell, and Aris is Senior Software Developer at Bunnyshell. Before we get started, few housekeeping items. You have a chat window on your right hand side, so you can put questions. We will do the Q&A at the end. And now over to Sorin to get started.
So, hey guys, very short intro about me. As Raul said, I'm the VP of Engineering here at Bunnyshell. This means I'm responsible for everything related to product engineering, from the processes and tools that we use, and ultimately for the quality of the product that we ship for our users. I have a background in software engineering, mostly in web applications, but some embedded development also some longer time ago. That's it from me. Aris?
Okay, I'm a senior software engineer at Bunnyshell. So basically, I'm trying to make Sorin happy about the things that he's responsible of. Okay, and yeah, I also have I don't know, quite a vast experience in software engineering in general, and let's get this started. So we gathered here to talk about I know, infrastructure as a code in general and Terraform in particular, and how this can be useful for your organization or for your own personal projects. Cool. So let's get started. And what we will talk about today is a quick intro about IAC, infrastructure as code. Yeah. We will then talk about Terraform and GitOps and how we can avoid the configuration drift. We will see what that means. Is not quite a new concept, but is not that well spread. We'll see what it means. Then we talk about the basics of Terraform and its architecture and how it works. Then we'll go through some key considerations, what it means if you want to adopt and start using Terraform, and the things that you should be aware of when you will do that. Then we will see how we can integrate Terraform in our application code and applications workflows in general. And then we will see a demo of how we, for example, can use Terraform to provision some infrastructure for some demo application. We will see that in the second part of the webinar. Okay, so let's get going and start with a quick intro. Sorin will get us through a quick intro. So Sorin, let's see what's IAC about.
Okay, so as the name suggests, infrastructure as code, it implies that you'll be able to describe how your infrastructure looks and mostly behaves through writing code, as opposed to having to run commands or SSHing into servers and so on. So very simply put, you're enabled to write some code that will define your infrastructure, create it, and then probably handle the upgrades as well. This also depends on the tool that you're going to use.
Okay.
So very important question. Why should you care? Why should you use it? From my point of view, these are the four main benefits for using infrastructure as code. So it's clear that above a certain level in operations, you need to be consistent. You need to be able to replicate things. You need to be able to, for example, create another slave for the database that's identical to the slave that you already have. You need to be able to provision more web servers, also identical to the ones that you're currently running, and so on. So you need to be able to replicate results in a predictable manner, basically. This ultimately allows for faster processes, and these faster processes are a real benefit over time. So when using infrastructure as code, in the beginning at least, the first piece that you'll do probably will be slower than if you do it by hand, because you'd have the learning curve, obviously, but you'd also need to think things through and organize the code, maybe put out some modules, document some more, and so on. But once you do that first piece, that first resources, the rest are replicable very, very fast. So if you'd need 10 web servers, you'd take some more time for the first, but the next 9 will be done in a blaze, like minutes, and they'll be identical with the first, which is really, really important, and it ties to consistency.
Okay, so that's nice. So that's what's also true is that sometimes it will be a lot faster to actually click a checkbox in a UI and click save. Even do that 10 times for 10 servers. And it might be actually tricky and complex to do that with IC if the SDKs lack that support for that endpoint. So that's true. Some things might be slower at some point, but yeah, they get fast eventually.
Yeah. So thank you for the addition, Aris. Yeah, this is a real good example in comparing cloud UIs versus infrastructure as code. So it's by far one of the best practices that are adopted by every DevOps, basically. Moving on to the next thing that provides real value, and I'm referring to traceability. And we all know what becoming compliant and then staying compliant with given standards in security and quality or other IT related standards means. You need to be able to provide access at the minimum required level, and then have an audit trail for each and every change that was made in the both infrastructure as code, but for the infrastructure part, having a tool definitely helps with this. And last but obviously not least, the documentation part. It's probably the most tricky to keep in check, because we all know how it gets after you finish a task, especially a daunting task. You're so happy that maybe you think that you just skip the documentation and write it maybe tomorrow or something like that. But it's a manual process, and as each manual process goes, it's error prone. You're subjected to forgetting things or documenting them maybe not so correctly, and this happens even for the most organized of us. So these are the benefits that I see, which in turn lead to some business benefits. And this obviously goes into reduction in complexity, and reduced complexity means that people will be essentially happier, and they'll allow for themselves to think more of important things that they need to do. So instead of being very stressed out to replicate the I don't know, X task, right, 10 times, they know they do it once, and then they have the mind free to think of something else that brings real value and not waste energy on just not screwing things up. And all of these ultimately lead to a cost reduction, because you'd have less rework, less incidents due to infrastructure changes, and much more fast reproducibility. So you'll be able to cut pretty much time of, let's say, work that is totally automatable, right?
Yep.
Okay, there are a bunch of tools that can help with with this. Aris will dive a bit deeper afterwards. They're all a bit different, have pros and cons, but these will be tackled later on.
Yeah. Okay. So there are a bunch of tools. Some of them are newer. Some of them are actually really old. Yeah. And none of them really is good for everything, or is very good for everything. But obviously, some of them are more popular, are maybe easier to use, or have a larger community, which fuels the development of the tool. Some of the more popular ones are Ansible, Puppet, Pulumi, which is actually probably the newest one in this list, Chef, Terraform, AVS Cloudformation, and for sure there are a lot more than this. Even built-in tools and a lot of things like that. Many companies built their own IAC tools. Yeah. So, okay. So this is the list. We won't go in details through any of them. It's out of the scope for us. But let's check out just three of them to see somehow the main characteristics of a IAC tool, and what we can talk about when we are comparing tools, and what we should take into consideration. So let's take a look at Pulumi, AVS, Cloudformation, and Terraform, our main subject for today. And when we are talking about these tools, the main characteristics we care about are if it's a declarative or imperative tool. Declarative means you are defining in a format the state your infrastructure, or the way your infrastructure should look like, and the tool makes all the needed adjustments for that. Imperative means you will actually write code and logic like a program, and you will instruct the tool step by step what it just needs to do to get to your desired state. For our three tools, Pulumi is actually purely imperative. You are actually coding. They have a bunch of SDKs for a lot of languages, and you are actually coding your infrastructure, truly coding it. Then AVS Cloudformation and Terraform are declarative, but this is subjective, because the way Terraform works, for example, and for sure Cloudformation, you are writing a definition file, but that translates back to actually running code, which is declarative, which is imperative actually. But yeah, we can split them by this. Then we can also split them by the way the infrastructure is, if it's mutable or immutable. Some of the tools are actually designed to change and update existing infrastructure, and some other tools are designed to better recreate and reproduce infrastructure for blue-green like deployments. Yeah, I want to change my server, I will just deploy a new server and then get the old one back. And this is actually preferred nowadays, because updating something that is already existent has different risks. So it might be more complex to actually create a new database and migrate your data to it somehow. Yeah, it's more complex, but it's safer than to change existing configuration, to just recreate it from scratch with the new configuration. So in regards to this, all of these three are immutable, are designed for immutable infrastructure. Then we talk about agent or agentless if the tools requires an agent on the infrastructure side of things, be it some servers. Yeah, none of them requires an agent. Yeah, for example, when we talk about agent, we think of Puppet, for example. Yeah, Puppet has an agent on the machines it manages. So all of these three are agentless. Then another very interesting characteristic if the tool is designed for provisioning or for configuration. Provisioning means it creates your infrastructure, like it creates servers, load balancer, VPCs. Let's talk about servers. It creates servers, but it's not configuring them. It's not installing packages. It's not configuring the firewall on them. Yeah, so that's configuration, and some of them are designed to do only provisioning, and it's actually hard to do or difficult to do configuration with them. From these three tools, yeah, that's the idea. They all can do both provisioning and configuration, but they all three are mostly used for provisioning. Of course, you can extend Terraform and add a SSH provider, and you can do absolutely what you want on the server with Terraform. Yeah, and you can do configuration. But their main focus is provisioning, but yeah, they can also do configuration. Cool. Yeah. Okay. And now about costs. Obviously, for all of them, the infrastructure you create with them will cost you. Yeah. But besides that, Cloudformation and Terraform are free. Of course, Terraform has an enterprise edition, has a cloud. HashiCorp, the organization behind Terraform, offers a cloud where you can manage Terraform modules and actually use them. That obviously costs, but they are free. You have all the features for free. Pulumi, on the other hand, it offers like a personal free license for personal projects, but if you want to do anything just a bit commercial, you will have to pay some monthly subscription for it. So yes, yeah. So we just took a look at three of them. Of course, SaltStack is also a popular IAC tool. Yeah, we just randomly picked three really. They are all interesting in essence. Yeah, Terraform is very popular. Pulumi is the new kid in the block, and AVS Cloudformation, it's one of the first modern IAC tools, let's say. Okay, let's talk about configuration drift, and I think Sorin is very fit to drive us through this configuration drift thing. Yeah. Okay.
Yeah, so I'm gonna try to keep it short here because it's pretty straightforward. Configuration drift is about having different configurations on a resource pool, which should have identical resources. So basically, that's where the drift term comes from, because it drifted a bit, or more than a bit. We can see in an example that I've prepared. And this usually happens when the changes performed for the infrastructure are not well documented, are not tracked, and for sure when they are performed manually. Because manual steps mean, as I said, an error-prone process, which is it's basically just a matter of time until you screw something up. It's not about if, it's about when and how often also, right? As time passes by, as most problem, this doesn't solve itself. It only gets worse. So obviously, if the number of changes keeps adding up and also the complexity increases, this will only get worse and worse until it can be quite a showstopper for releasing anything into production safely, right?
Yeah. And it can be very costly, in regards of the intro.
Yeah, exactly. So this leads to incidents. This can also lead to very, very high times spent in debugging. So it will delay projects. It will steal resources. It will steal focus from the team. It's really, really bad in terms of cost, and not only money, but opportunity cost, because you'd have to spend the very precious resources that you have allocated on building projects. You'd have to spend them on debugging, and obviously the projects wouldn't finish themselves. So no value brought to the business there.
Okay.
Okay, so we can move on to the next slide, Aris. This is the example that I've been mentioning before. So let's take a very plausible, in my opinion, situation. Let's say you have an e-commerce which is pretty successful. You're running it, the web application, I mean, you're running it on free web servers. Let's ignore the database, caches, queues, and so on for this example, for the simplicity's sake. So let's discuss only about the web servers. Let's say you have Rebecca, which is a very organized and senior member of the IT operations team. She goes in and provisions the web servers, partially from the UI, partially from SSHing and running commands through SSH on each of the web servers, and then also thoroughly documents the changes down to the letter. Afterwards, Rebecca eventually goes on vacation. This is unavoidable. And Matt, her colleague, is required to perform a pretty minor change to install a PDF library, let's say, that will be used to generate invoices for customers. He goes in happily and does this, but unfortunately, he forgets to update the documentation that Rebecca created, which with so much care. He knew about the documentation, but just forgot because he was just filling in for her and got pulled out of a bunch of other tasks that were pressuring him. So moving on, after some time passes, obviously Rebecca returned from her vacation, and good news, the web shop is drawing more traffic, so we need another web server to it. Rebecca goes in, she knows her documentation is impeccable, follows it down to the last details, and raises another web server. But obviously, since Matt didn't document the change, this server is a bit different, and roughly 25% of the invoice generation requests will fail now. Let's spice it up a bit, and let's say that a vulnerability is found for one of the packages on the operating system, right? It's basically the simplest task someone can perform, so they assign it to John, which is the junior in the IT operations team, and he's very excited to do another simple task in production. It's not his first one, so he's not extra careful, and unfortunately, he misses one of the servers. He applies the change on all of the servers except the second. So even after this fairly simple scenario, you can see illustrated what a mess the configuration has become. And we're only talking about 3 changes in production here. Imagine doing this between other projects which you're juggling with and doing them manually. This is bound to happen. It's not, again, it's not a question of if, it's a question of when and how often, right?
Okay.
So this will lead to serious difficulties in bringing the documentation up to date, and also serious issues in bringing the configuration of the servers to an identical state, because it would be very hard for anyone to know exactly what was run and where. Sure, you could look into, I don't know, Linux history and cloud audits, but it could become really messy really quick, because there might be different users involved and so on. So it would be a pain, a real pain, to reconstruct all of this.
So let's see how we can. Sorry, let's see how we can avoid this.
Avoiding it. First of all, it requires clear processes which all the team members must follow, but it also requires some checks in place in case not all team members follow the processes, right? Because we're humans after all. So it would be a very good idea to have all the changes performed from a single point, and this could be a tool of infrastructure as code. Obviously, the changes we already discussed about this, they need to be documented in detail. Regarding the part in which I said there need to be some checks in place in case someone skips the procedure, well, change monitoring handles this. So you need to be able to recognize if something has changed besides the project, the process, sorry, on the sidelines, on the server, on the servers, and expanding this to a more general term to any resource, because it might not be a web server, it might be on I don't know, AWS queue or anything really, right? Still regarding to having checks in place, it's a really good idea to perform regular audits, and this is also why the audits are required if you have IT certifications. It's a really good reason to do them, and at least you get the chance to catch some things that have slipped as early as possible. Obviously, using a tool, an infrastructure as code tool, greatly helps with most of these, or can help with most of these. It also depends on how you use it and on your process, but it can greatly help with this. And also having the code that generates or updates the infrastructure, I mean, having it versioned is a really good both documenting and also traceability point. And as an added bonus, you could trigger this automatically. So you could have a process and do it with Git, let's say. You'd have certain people allowed to approve changes, and these changes could be contributed by any member of the team. So they could create pull requests, but only a certain pool of experienced people who have the clearance basically to do this could approve this and basically trigger all the process. So you'd have a single manual step in the whole process, and this would be approval. So no input, no change there. It's everything as it's designed to be. It really works beautiful in real life and saves a ton of issues for companies.
Okay. Yep. Nice. So let's see actually how. Yeah, let's get to our subject Terraform and see how actually Terraform works and help us avoid the drift. This is sort of the architecture of Terraform. We have the configuration files that are written by I don't know, operation DevOps basically, yeah, or even developers. It's configuration files. Then Terraform maintains a state of how the current the infrastructure looks like currently, and the configuration basically says how it should look like. Then Terraform does a diff between the two and executes different API calls or whatever is needed on the services providers to bring the state to the desired state. And of course, this state is really important, as we can actually feel like it's something important. And the state can be stored in remote storages, encrypted storages. It contains basically a full information about your infrastructure. It for sure will contain secrets and things like that. So it can be stored remotely, encrypted. Yeah, we will see some more about this. Then we have a sample of code, how these .tf files look like. The syntax in which these files are written is HCL, is something created by HashiCorp, and it's actually used for configuring most of their tools. Yeah, so it looks like this. It's block of codes with providing values to different attributes, and yeah, configuring the provider of the block of code. And here, for example, we initialize a provider for AVS, yeah, and we give it the credentials for the AVS, and then we are creating an EC2 instance, providing a specific AMI and an instance type, which is coming from a variable. We will see what this is and how many of them we want. Yeah. And yeah, Terraform has a CLI and obviously and a bunch of commands. The main commands that you would use on a basic workflow are refresh. This is deprecated, was moved to the apply command as an argument, but it's refresh, which is pulling the information from your providers to the state, is updating the state. Okay.
If I may interrupt a bit, Aris, so you mentioned the state and it being stored in a centralized place, basically, somewhere. It doesn't matter, right?
Yeah.
How about larger teams in which you'd have many people working on the infrastructure, each of them producing different changes, and all of them needing to be going together, perhaps live or at very close intervals of time?
Yeah. So basically, running Terraform will update the state, will write to these state files. So obviously, it's obvious from the start that if you would run Terraform multiple times on the same state, you will run into a corrupted state. So what it does, it has locking mechanisms. Basically, the storages where you can store the state, the drivers it has, they also come with a locking mechanism depending on the storage. If it's like on your file system, which is not distributed, you basically get a log file that is created, and you cannot run Terraform again there at the same time. Then on S3, for example, you can store your state in S3. The locking mechanism is implemented on DynamoDB, so you would also need a DynamoDB service, and it will use that to create the locks on the S3 bucket. So yes, this is how they fix it. Basically, they don't allow it to be run multiple times at the same on the same state, yeah, at the same time. Yep. Yeah, that's really important. Then the commands, the refresh, it's updating your state with what you have on the in the providers, in your services providers. Plan, it's creating the plan and showing you the plan, the executions that it will do to to bring the state to the desired state, to the state that you desire. It will show you the changes it would do. Apply is applying these changes and updating your infrastructure, and destroy basically destroys the infrastructure it manages. Yeah, that it created, it will just clean it up. So that's the basics of Terraform. Now, an important topic, the key considerations when using Terraform or deciding to use Terraform. Some of them apply to any IAC tool, like always use Terraform. So if you really want to do this and have the full benefits of an IAC tool, you should be disciplined and always use it. Yeah, like don't cheat if it's just a checkbox. Try to do it using your IAC tool. So that's one of them. If you start using it, always use it. Otherwise, you will still have drift and you will still have issues. Another thing is split everything. It's still code, so it's infrastructure as code. You need to use the best coding practices. So do not have huge blobs of code. Try to split things around. Terraform has modules. Yeah, the third point has modules. You can extract repetitive things from your code into modules and reuse those. Then the fourth point is like a con, actually. Sometimes the state gets corrupted, depending if you made manual changes to the infrastructure, or if your the libraries that you use in Terraform have various bugs, the state can become corrupted, and you will have to actually manually manage it and fix it. There's no easy way for that. Yeah, it's actually yeah. You really need to do this. If you decide on working it, you will hit this at some point, and there's no easy way out of it. Then you can fetch, this is actually not a key consideration, but you can fetch external data into your Terraform code, even HTTP endpoints. If you have something that is configured in some external web service, you can fetch the configuration from there in your Terraform code and use that for your infrastructure as code provisioning and so on. Then Terraform has a nice expressions feature. You can do a lot of things with it, really. Like, for example, this block of code. You have variables. You can format strings, and this is really the simplest examples of them all. Yes, you can do for eaches, loops, and the thing with it being declarative and not imperative, it's that it's not looking very natural. It's not looking exactly as you would program something. Like, for example, this thing over here, which creates IAM users. It actually creates multiple users. Yeah, it can create a number of users, and the name of each user sits in a list, and you access the list like this. It's not extremely intuitive. Also, let's check this example. We create an S3 bucket, but we basically want the option for our Terraform code to create or not create the bucket, depending where we run it. Maybe in an environment we don't want that bucket. There's no if. There's no if condition for that. We need to use this trick using the count variables and setting it to 0. So it's nice. It's pretty advanced, but the flow logic looks a bit weird in a declarative language. Yeah. And then there are no easy rollbacks. There's no rollback feature like Terraform rollback. Basically, rollback means you return to a previous version of your code. If you are using versioning, you just revert to a certain version, a revision, and you just reapply your module. Of course, that doesn't work always out of the box. Just doing that. Maybe some things will need to be manually reverted. So really no easy rollbacks. Still depends on what you manage and what's your exact use case. I know, and it's no easy rollbacks, and it's worth mentioning because other tools provide actually quite advanced rollback mechanism, like Pulumi that we talked about a bit earlier. They have a rollbacks feature. So this is for Terraform, the things you should keep in mind when deciding to use it. Then how you can connect your Terraform, actually your infrastructure code to your applications. Yeah. So basically your application needs to pass input to your Terraform code. Then it does something, it creates infrastructure, and it has information about the infrastructure, IP of servers, for example. That you need to get into your application. Yeah, so for this, Terraform has this concept of input variables. Input variables are variables that you provide when you are executing your Terraform code. They can have default values and a lot of features. So here is an example for the backend instance type variable. This is the name of the variable, is of type string, and it has a default value for T2 micro. So this, our module right here, has this as an input variable. Then it has the output values for providing the details about the infrastructure it just produced or updated, or manages. Yeah, you can always pull output values from the state. You don't have to do necessarily a Terraform operation. And for example, here we are outputting the backend IP output value, which contains actually the public IP of the EC2 instance we just created. And then we have the backends, which is basically the place where we store the state. Again, it's really important. We talked in a previous slide about the state and how important it is. The storage for the state is called the backend, and it supports a bunch of drivers. And yeah, this is just an example for storing it in S3. We provide the bucket name, the key for the file, and obviously the authentication details to that bucket. So yeah, these are the three main concepts that help you hook your Terraform code and infrastructure details that is automatically generated, yeah, into applications in general. Yeah. Now let's see about our demo. Our demo is a bit interesting. I don't know why would anyone do this, but I think for fun. Okay, so our demo consists of a voting app. It has two components, actually three components, and the API, the front end, and a worker. Yeah. So on the front end, we can vote. We'll see the app, of course. We can vote on the front end. It goes to the API. The API stores that into a database. Then the worker pulls the votes from the database and generates a report and write it into an S3 bucket. Now, the API and the worker are hosted in a Kubernetes cluster together with the MySQL database. For the front end, we went for something really interesting. We are storing it actually in an S3 bucket, yeah, which then we activate the static website option, and then we are using Cloudflare to create a CNAME on a domain to that bucket static website endpoint. Whoops. Okay, and this is our front end. So this is interesting. So for all of these, basically the part of the buckets and the IAM users that have rights to do things on the buckets, and the Cloudflare management, where we'll create the DNS record with the CNAME, will be done by a Terraform module. We'll see it, of course, and the rest will be deployed. Yeah, just using Bunnyshell, we will see it really fast. Is totally out of scope. We won't go into any details about how this gets deployed. Yeah, we will just take a look at how these resources are created. And basically, the use of Terraform here is not just to use it as a, I don't know, sort of CI pipeline or something, force it into that. The use of Terraform here is that we will actually see how we can reproduce this infrastructure easily for multiple environments. Like we can create like that an environment with its own infrastructure, meaning its own buckets, its own front-end deployment, and its own CNAME in our Cloudflare managed domain. Yeah. So yeah, let's jump into that. We have our I will bring on other windows than the presentation ones right now. 1 second. Okay, so we have our we have a repo which is public, and it's we have the address here obviously, and it will be on the last slide of the presentation too. It contains basically all our app, the backend, the front end, and our Terraform module, which is the interesting part. We will just clone this repo and see how the Terraform part works. Like we will just try to use the module and see how actually it works. Let's clone it first. Yeah. Okay. And let's look through the code just a bit. We don't go into details, but just to make a sense of what it means. It contains some things are tricky to do. Not everything is simple to do. That's what I said somewhere at the start. Even clicking a checkbox, which might look easy on the UI, might be tricky to do programmatically, yeah, through APIs. So let's look at our modules. We have a list of providers. Okay. We are using the AVS provider because we need to create those S3 buckets. We are using the Cloudflare provider provided by actually Cloudflare. Yeah, it's an official provider for Terraform to manage our DNS records. And I don't think I'm using this actually. It's just a provider to generate almost truly random things provided by HashiCorp. So let's then take a look at our input variables for our module. You can have here normally like 100 of variables easily for a bigger module. This is just our module that does very few things. It needs an AVS region for the AVS provider, a Cloudflare domain on which we will create our DNS records, an API endpoint URL. We won't go into many details about this. Maybe you can send your questions after this. This is used for the front-end deployment, so that the front-end deployment knows what's the corresponding API service, API endpoint for it. Yeah. And then we have a prefix. The prefix is used to prefix all your resources names, so they can be unique. So if I want to recreate the infrastructure created by this module in the same account, in the same AVS account, I can just change the prefix and they all will be unique. Yeah, I don't know, if you work with Helm, for example, it's a super common practice in Helm to prefix all your resources with the name of the release. Yeah, it's something really similar. Anyway, now let's take a look at the outputs before we jump into the actual resources blocks and what it creates. Our output is the website URL, which is not actually used by the application. It's good to be verbose with your outputs and output as many things as possible. You never know when they will actually be useful. Yeah. Then we have the access key ID and the secret access key for the IAM users that will have access only to the reports bucket, so the workers can use it to write into that bucket. And then we have the bucket name, yeah, for the reports. You can mark output values as sensitive, and they won't be displayed by default in the Terraform output and logs. Yeah, they will be obfuscated. So that's what this flag is for. We'll see how it looks like. Then our main file. This is the actual declaration of resources. And as we talked, as I said before, it's declarative IAC tool. So you just describe basically the state that you want to get. You don't have to provide them in a particular order or anything like that. That's actually important. Terraform will decide the order in which they should be executed and the resources should be created, and it will do things in parallel for you. Yeah, it just creates a direct acyclic graph of your resources based on their dependencies. And the dependencies are pretty clear because you are using variables from other resources in subsequent resources. And there where you are not and you want a resource to wait for a previous resource, but it's not obvious that this resource depends on that, you can add a depends on block. Yeah. And then it will, like this example. This example is not using anywhere. This resource block is not using anywhere this. So I actually had to specify this for Terraform that it should wait for this before creating this resource. And now let's quickly look through it. We instantiate our providers. We instantiate AVS, instantiate with codes. It's a way of calling it because we are talking about code maybe. So we are instantiating this AVS provider with the region provider from the variables, from the variable. If you want to use different regions in the same module, yeah, we can alias these providers and instantiate AVS multiple times with different arguments. Then we are declaring our Cloudflare provider, and then this is just local variables. We are computing. We are using some local variables for some repetitive computations or expressions. Yeah, here we are computing the Cloudflare subdomain name. We are prefixing it with the demo and the API endpoint URL. We are doing a bit of templating. Again, we won't go into details on this. We can talk later, I guess. It's maybe a bit longer discussion for this. We have the API endpoint URL. This is what matters here. And then we are declaring that we want an S3 bucket. Yeah, we call it site. Is like the name of the resource in this code, but its actual name in the cloud will be this. There's no need for this particular name. I just wanted to name it like this. The subdomain and then a dot. It will be actually the host of the front end website. Then we need to specify force destroy because it won't be an empty bucket. And when we will run Terraform destroy, it will errors out. AVS won't let it delete that bucket because it's not empty. We use force destroy. So before that, it will empty the bucket and then delete it. Yeah, and this is just the configuration for a static website option. Then we make this bucket public. It needs to be public so we can serve it as static website. Then we define a bucket policy for the bucket that will hold the front end. We need for everyone to be able to do get object on it. Yeah, this is just AVS very specific things. Yeah, but we are opening the bucket. We are making it public because by default it's private and blocked. Then we will start creating the Cloudflare subdomain. Sorry. For this, we are fetching informations about our Cloudflare zones, and we are filtering the one that actually it's interesting us. A zone is basically a domain, so to say, in Cloudflare, and we are actually interested in working with a specific domain and update the DNS records of a specific domain. So we are using this variable to target that domain. Yeah, in this slip here, basically, Yeah, we actually. One second. Yeah, we are fetching again here. Now the providers have glitches and bugs. They actually have so much code, and a provider like the AVS one for all the AVS services, it happens to have glitches. So here I would normally be able to use. I need to use from the side bucket that we just created to extract the website endpoint that was assigned to it. Yeah. So in order to do that, I could normally just access the bucket where I declared it here, like AVS S3 bucket site. But because of a glitch, I need to refetch the data like this about that bucket. So I have a data block. Data block means that Terraform will just fetch data about something, and we will fetch the AVS S3 bucket with this name. And then we will create the CNAME record. We provide here the zone ID in Cloudflare, the name of the subdomain, the value for the CNAME target, basically. Yeah, so here we are getting the website endpoint assigned by AVS to our bucket that we want to make it CNAME. We put a very tiny TTL so we can play with this. And yeah, that it's actually proxy to Cloudflare. Doesn't matter, it just details. Yeah, and then here is the interesting part, that you can actually even I don't know, deploy things with Terraform. Yeah, here we uh, uh, we have a question about testing Terraform code, and we will keep that for. I don't know. I can specify like this. IAC in general, it's code. Yeah, it's code. So code needs to be tested as a best practice. You can have bugs in your IAC. Yeah, obviously. So that's why we have unit tests, we have integration tests, end-to-end tests. There are some tools which can help you testing a Terraform code, like TerraTest from Gruntworks. But yeah, we won't go into details. But they basically, let's say, they offer you an SDK which acts like a wrapper over the Terraform CLI, and then they offer you a bunch of helpers with which you can assert the output of the Terraform commands. Yeah, so this is what it does. It's sort of an integration test, not exactly unit test. For other tools like Pulumi, which is imperative and you are actually writing code, you can actually unit test that. Yeah, yeah. So the IAC is totally testable, and you should test it. You know, it's basically the next level for making sure you don't actually have bugs in it. So now, getting back to our example, we are talking about that you can actually deploy things with Terraform. There are so many providers that you can do basically anything with it. You can SSH on machines and do anything. Yeah. For example, what are we doing? We are actually uploading the website assets to the S3 bucket, and they are here in a folder in Terraform. There's a build command that is building the front end and copying the files here. And yeah, it's not your to-go architecture for deploying something like this, but it's just for the demo purpose. Then we are using this module to list the contents of a directory, and then for each file that we just listed recursively, we are uploading it into the site S3 bucket. Yeah, this is what this does. And then we are preparing a bit the index HTML file. Again, these are specifics and details. What we are doing here is replacing the endpoint of the API with the endpoint that we are basically getting from the variable. Yeah, this is a local variable which is using a variable for the module. Yeah, and we are setting, basically we are updating the front end code to use the specific API endpoint that we need to use for this deployment. And then we are creating an IAM user for the reports bucket. The reports bucket, we allow the user, the IAM user, to access only this bucket. And yeah, this information is important because it basically will need to get into the worker configuration, so the workers knows the access secret key, access key ID, and the bucket name to use to upload the reports. Yeah, so this is our code. We went quite into details about it. Let's quickly see it running. First of all, we need to do an init to pull the yeah, we need to go in Terraform directly. Yeah, to pull the dependencies, and so it downloads the providers, and then we will execute a plan to see how a Terraform plan looks like. Okay. Okay, so now I have exported in this shell environment a few things. I have my AVS credentials of an administrator user on this test account. It's just a free account. Even if they would leak somehow, they won't leak. You can't do anything about it. Okay, and the Cloudflare API key. So they already exist as environment variables, and their providers know how to read them from environment and use them for authentication. So now I will use Terraform plan, just plain like this, and Terraform interactively will require the variables that are defined in the module, and don't have already a default value. So we can do this, or we can provide the variables as arguments. Yeah, just like this. And let's see how the plan would look like. How a plan looks like. Now, basically, it fetched from AVS and Cloudflare information about resources and made a diff with what we want to achieve, and it created this plan. Yeah, and we can see here with plus it's create, and we see it will create basically what we have in all the resources we have defined in our main TF file. Yeah, we see the outputs it will provide. Some outputs are already known. They are maybe just variable and expressions, computations. Or some of them we'll know after we will apply the module. Yeah, like the AVS IAM user credentials. And now let's apply it and see what happens. Before that, let's check it out. So this is the AVS account, and these are some buckets related to our demo. We will create another one. What's important to see that we'll create some new buckets. This is the Cloudflare dashboard, and we can see the present CNAMEs here. Actually, 1 second. Oh, like that. And yeah, let's see what happens after we apply our module. Yeah. 1 second. I want to just change the prefix to something like hello. Yeah, let's use hello. And again, it will display the changes that it will do, sort of the plan. Yeah. And we accept the changes, and yeah, we get the output. It creates the resources in the order of the graph that we talked about. It does stuff in parallel. At first, I thought about using SRDS for this demo, for example, but certain resources obviously take a lot of time to get up in the cloud, like an RDS, for example. So I just went for the faster way. So it created our resources. We see our output values. We can see that this is marked as sensitive. So because we asked it to do this, we can actually see them like this in plain and exposed. Yeah. Okay. And now let's see the buckets that were created. We are creating 2 buckets. This one is for the reports and it's empty. This one should contain our front-end website. So here it is. Yeah, we should have the CNAME here created. Yeah, we got the CNAME, and we should be able to access it. Okay, and we have our front end here, and we will just take a peek at the requests that are being done because we are technical here. So if I vote, yeah, a request is being done, and it's being done to this endpoint. Yeah, we will see where this endpoint exists right now. And we specify that endpoint in the apply command right here. Yeah, so this is where it comes from, and it was replaced, injected in the front end files. Yeah. Okay, so this is our app, and this was our demo. We will also demo the destroy command. Yep, very important command. Basically, it will delete the buckets and the CNAME. So now let's see how we are actually at Bunnyshell integrating Terraform modules into applications. It's just an example. This is maybe you could use your CI/CD tool or pipelines to use Terraform. This is the way we integrated it. Of course, confirmation. And again, it's out of scope of presenting exactly what Bunnyshell is, or okay, let's okay, before jumping into this, if there are any other questions, let's answer some questions, because we are going further and further away from the presentation, and just to not forget your questions or ideas.
So I see a question regarding the rollbacks. How do you handle rollbacks for Terraform?
Okay, so rollbacks are handled just by reverting to a previous version of your TF files and applying them, and hopefully the changes it needs to roll back are rollbackable, so to say. Most of the times, almost every time it works, except when it doesn't, and then it hurts. Yeah, you need to start when it doesn't automatically works. You need to actually manually roll back the changes, and then manually help Terraform refresh the state, which might mean actually use the Terraform CLI to actually modify the state files. It can get dirty, yeah. It doesn't happen often, yeah, but when it happens, you need to know what to do, yeah. Okay, so another one, how are secrets handled by Terraform? We just saw the output values. You know, there's maybe different levels of managing secrets, like input variables or output values, which contain sensitive informations. You can mark them in your Terraform module, and Terraform will not display them anywhere in its output. But then it's about the application secret or credentials to services, or I don't know, certificates, things like that. You can actually store them in other cloud services, or use Vault from HashiCorp, yeah, their own secret storage service, or you can store them in any service, basically. And what you can do then is to actually fetch them in the Terraform module, if that service, and the most popular one, provide a provider for Terraform. You can actually use Terraform to fetch the secrets from the service. Of course, you will need some sort of master credentials. You will still need to provide some credentials to Terraform, but you can keep and manage your secrets somewhere externally, and Terraform can actually pull them from there and use them. Yeah. Okay. What we see is the most important aspect of Terraform to understand before, yeah, definitely the most important aspect is understanding how the state looks like, and how you can manually alter the state. Learning and understanding the CLI commands for that. Yeah, you can. I mean, in Terraform, almost every time it manages the state and refreshes it itself. Sometimes you will need to manually import resources into Terraform to have Terraform know about them and manage them. You sometimes need to remove resources from the state. Maybe somebody manually removed a resource from the cloud. Terraform will error out that it cannot find that resource anymore. It knows it created it, but it cannot be found anymore, and then you would need to manually remove it from the state to be able to use the module again. Yeah. Yep. So yeah, if there are not aren't any more questions, I will pass it to Sorin for some closing words. Thank you. And maybe we'll see this demo in a future webinar or something. Yeah.
Yeah, for sure. Thank you very much, Aris, for the very detailed demo and comprehensive. Don't forget that you can see the code. It will be linked to this presentation. So if you have any further questions, please don't hesitate to reach out to Aris or to me and get a conversation started. Thank you very much for attending, and have a great day ahead or evening ahead of you.
Thank you.